In the previous video in this series, we introduced the advanced setup section and edited the key cost and price data. In this sixth video, we start to look in more depth at some of the more advanced setup options that allow you to tailor the model to your specific circumstances. In particular, how to adjust the feed-based growth model. There are various approaches that can be taken, but here we have chosen to base the model around feed tables that are usually provided by feed manufacturers. In simple terms, the growth of the fish depends on sufficient feed being provided for them to achieve their optimum growth rate for the given conditions. As feed is usually the most expensive input, the profitability of the farm depends on ensuring the feed is converted into fish meat as efficiently as possible. The growth model therefore uses three interrelated numbers: the specific feed rate, the specific growth rate, and the feed conversion ratio. This approach sacrifices some accuracy for relative simplicity and flexibility. A key point is that all three figures change during the production cycle. Let's look first at the feed conversion ratio. This is commonly measured across a whole production cycle and quoted as a single figure. However, in reality, it gradually changes as the biology of the fish changes, as well as being affected by the accuracy of feed management. As fish become larger, the feed conversion ratio also increases, i.e. more feed is needed to achieve the same increment in growth. In order to accommodate this, the spreadsheet gives you the option of either using a formula to predict the FCR at different fish sizes, or you can enter FCR values directly into a lookup table. The choice between using a formula or specifying values directly in a table is selected on the 0-Start Here sheet using a drop-down selector. The parameters for the FCR formula are set on the feed table sheet. The formula is shown at the top of the feed table sheet, i.e. FCR equals A times ln brackets weight brackets plus B. Using data from Scretting, we've suggested values for A and B for different temperatures. However, you can adjust these figures to fit your data where that is available. The results are displayed in the growth table, where you can see the FCR value gradually increasing with average fish weight. Alternatively, you can select Table on the 0-Start Here sheet and enter FCR values directly into the feed table on the custom FCR row, e.g. based on your own measurements. The next thing to look at is the specific feed rate, SFR, which is the amount of feed fed per day expressed as a percentage of the fish weight or biomass. Feed manufacturers provide feed tables to show how much to feed at different fish sizes and temperatures. In practice, these are only a guide, but can be used to provide a growth model on the basis that the amount of feed fed divided by the feed conversion rate gives the growth increment of the fish. Feed tables are usually set out as a matrix of water temperatures and fish weights. The cell where each of these values intersect gives the specific feed rate, i.e. the percentage of biomass that should be fed per day. It is important that the temperatures and fish weights are set out in ascending order. Feed tables themselves are often based on a growth model, and that is the case with the default feed table used in this spreadsheet. The SFR values are calculated using an exponential function, which works reasonably well over a short time period, but becomes very unrealistic over longer time periods. You can adjust the feed table by adjusting the equation parameters if you wish. The equation and parameters are shown at the top of the feed table sheet. Again, suggested values for A and B are given. The equation only provides the data for the specific feed rates at 26 degrees C. The feed rates for other temperatures are taken from a second table of adjustment factors. The default values for 26 degrees C are also used for 27 degrees C. The feed rate is adjusted downwards at both higher and lower temperatures by multiplying by an adjustment percentage. You can edit these values to change any value on the main feed table. This table can also be edited if you wish to further customize the model. Alternatively, you can directly enter your own SFR values into the feed table. You need to indicate this on the 0-Start Here sheet by selecting Custom rather than Temp in the drop-down selector. If you select this option, enter your feed table data in the row marked Custom SFR. Note that you can only enter data for one temperature, which of course should align with the temperature that you have defined on the start page. The choices made on the 0-Start Here sheet are shown below the main feed table. The default values are to use the feed table calculated from the formula and give the SFR values, and to use the FCR formula to calculate the FCR. In this case, the SFR value shows the site temperature that will be used, which was set on the 0-Start Here page. If you decide to enter your data directly into the feed table, then your choices will be shown like this. Examples of the values used in the growth model pages are shown in the growth table section of the feed table sheet. The specific growth rate, SGR, is calculated by dividing the SFR by the FCR. In this table, the values are shown for the same selection of fish body weights as in the feed table. However, this is just for display here. The values are calculated for each individual day to improve the accuracy of the model. The table is also shown as a chart so that you can more easily see the changing values of SFR, FCR and SGR. Once you are happy that the model is a reasonable approximation of the performance you experience on your farm, you can return to the 0-Start Here sheet for further configuration. In the next video, we look at some other factors affecting biological production.